So thank you very much, Antonio. Hello, everybody. I will just give a small talk about how the infrared imaging can help and is used for improving the process in pharmacology. So first of all, as Antonio told me, I'm part of Xenics, but Xenics, in fact, is part of the Exosense group. So I will just give you an overview of it. Then we'll explain why you have to broaden your view and not stick just to the visible, what you can see, but also what is invisible with the other and you can reveal with the other wavelengths. Then we will have a focus on the infrared. So Exosense, shortly. So Exosense is in fact a group which is leader in detection and imaging. Xenics, which is based in Belgium, is now part of the group for a bit more than 1 year. And thanks to this acquisition, Xenics master now all the wavelengths, let's say from UV to long wave infrared. So the group itself is 1,500 employees, much more powerful and big than was just Xenics. And yeah, okay, so now we are a big group and we can, let's say, give not only our agility, but also our power to help our customers. So we are all over the world, but the group, let's say that the core is based in Europe, and Xenics itself is based in Leuven, and in fact, Xenics is part of the advanced imaging group that gather the Leuven group, the group in Roden, Netherlands, in Bensheim in Germany, in Grenoble in France. So we based our expertise and our growth on 4 pillars. The first one is defense surveillance. In fact, you probably heard about Photonics on another application, which is defense. So it's still a big part of Exosense Group. And there is a very big and growing pillar, which is the life science and the environment. And that's where we are involved too with the advanced imaging and also in industrial control. So here today we are in between the life science and the industrial control. And there is also a pillar in the clinic. So our Xenics is part of the business unit advanced imaging from Exosense. Advanced imaging, that means, let's say, image which with a digital output. So it's all cameras for defense, for surveillance, for environment, for industrial application, for process monitoring or whatever. And this from the UV to the long wave infrared. So that's what we are in. So UV down to lower than 200 nanometers, even visible with the intensified camera, then the short wave with line scan and 2D arrays, and long wave and cool long wave with the 2D microbolometers and cooled cameras. So all these cameras, in fact, are used for industrial application, and we will focus on the infrared. So what I want to tell you is, okay, visible, it's easy to control for process monitoring and so on. But we have to broaden our view and use all the available wavelengths that you can detect with the modern tool, and especially with the camera. So you can see here small pictures of what you can see with the visible for sure, but also in UV or in infrared. So, okay, it's different, but you can detect things very, very different. In shortwave, You have some chemical that have a very strong signature in shortwave. In long-wave, you see the thermal. Usually, that's what we call thermal imagery. Mid-wave, also thermal. You go to UV or X-ray, so you can see X-ray, can see inside. So that's another part. But today, let's focus on the near and short infrared and on the long wave, and to understand what can be the help of these wavelengths for the pharma technology and pharma processes. So in shortwave, first of all, you have to know that we offer plenty of shortwave cameras. So that means you get the digital output and you can, let's say, process the data, make detection, reconnaissance, and whatever with this data. So the first classical type of camera in shortwave that are used in machine vision or in process monitoring, it's the line scan. Why line scan? Because in a lot of processes, you have movement, so just a line of detection is sufficient, and the image is reconstructed real time by the movement of the item. So that's where you can use a square or rectangular pixel with very high speed, lower speed. We even have some sensors that go to space. And we have several resolution, several wavelengths, and some news are coming, even very small one just for spectroscopy. So if we focus on what is currently in use in pharmacology, so we have the two main lines, product, line scan. So the standard one, which is very compact, low power, lower cost, and the one which is the new generation, very, very high speed when you want to make a lot of measurement per second, or when you want to monitor very high speed processes. So basically, these cameras are split between the one with a rectangular pixel or with a square pixel. A square pixel is used just to see what is moving and to reconstruct a picture. So it's kind of imagery. And in shortwave, you see that it can make the difference between different items. So here it's for food sorting, but you have exactly the same application in pharmacology. And with a rectangular pixel, usually it's used to make spectroscopy, classical spectroscopy. So, and for sure, this is used to make chemical analysis. And that's one of the big applications in pharmacology to check the value of the component, of the existence of the component, the purity of the component inside pills and this kind of stuff. You also have a lot of cameras in 2D, so that's the, let's say, classical cameras such as GoPro, but in shortwave. From the very small one, QVGA format to the SIGGA format, so it gives you more and more resolution from 320 to 56 pixel to 1280 by 1024. Also with different kind of sensitivity and different kind of speed, even very high speed when you want to make typically, again, hyperspectral imagery on fast moving process. These are the cameras that are really dedicated for that. So now if you go to the application, what can you see with that? The first thing is, it's kind of basic, but it's very useful in industry and especially also in pharmacology industry. You can see inside. You can see inside a blister, for example. So you can check whether you are sure that you put the pill inside the blister and you are not disrupting nothing. And secondly, you can check that you put the right one with the right content. So this is really both process monitoring and quality inspection. So this is typically what you can do and what is done indeed in real life. Another point is you can see through typical bottle, and you can check whether the content is really inside the bottle, or again, whether it's full of vacuum, let's say. So even if the plastic bottle is not transparent to visible light. So that's really, again, process monitoring to check that you fill the bottle up to the right level. And after that, also quality inspection. So that's the first level. Then the second level is if you make analysis of the shortwave data that you gather with your cameras, then you can check what is inside. And really, if you don't mix the pills, and if this is the right pill with the right content inside. So using hyperspectral, so typically push boom with a 2D array and a spectrometer in one direction. So here you use it as typically a quality inspection to check that you did the right content on the right bottle, for example, or the right blister. So that's another, the second step. And then you have the third step, which is how much and what is the homogeneity. So with the hyperspectral and the 2D imagery, you can really check the content and the homogeneity of the content typically in a pill. And you can say, okay, average of the pill is this level of active content, but it's not really distributed properly in the pill. You can do that in a big powder basket. And again, this could be even worse because if it's not homogeneous enough, and you may not pick the right content in your process. So here, this is the third step. You know what is in, and you know how much and where is it. Okay, so this is typically things that are used in the pharmacology industry. Then that was for the short wave. Now, if we move to another wavelength, still in infrared, you have the long wave. So again, we have plenty of cameras in long wave, and typically one of the family is very useful for process monitoring. This is the cameras that are used for thermography. That means they give you the absolute temperature, not only the relative temperature, but also the absolute temperature. This could be used to check a process, but not only. It can also be used for very basic things. But very important one is the final step, the sealing. The sealing, to be sure that, yeah, it's well sealed. You will not spill the content, but also that you will not have any contaminant coming from the outside. So this is typically something that you can do by thermography, checking the temperature and the homogeneity of the temperature and the value of the temperature at the sealing area to check whether you reach the right temperature, you are not over it, it's homogeneous, and yeah, so that will tell you, yes, this sealing will be okay or not. And if not, then discard it and check a new one. Okay, so this is typically quality inspection, but you can also use this thermography for homogeneity of temperature during a process. So that's what I wanted to show you. Okay, from the exosense point of view and the Xenics point of view, you have to know that this is our skill, definitely the infrared imagery, and that's one of our big market, the process monitoring for life science, for pharmacology, for food, for all this kind of biological stuff, let's say. And here I focus on long wave, but we also have UV application. We are purely European, so there is no, especially nowadays, there is no trouble of can you get the item from the other side of the world. Chinese no ITAR content, so it's very easy from an administrative point of view. As I said, we are part of the Exosense group, so now we are much more strong. And very important, we are very keen to support our customers. So because the use of infrared, as it is not visible, sometimes it's a bit tricky to understand and to optimize. In fact, usually customers, they understand, know why they want it. But to optimize it, it's another point, and that's where we are good at. And that's all for me today. So open to discussion. If you have any question, I will be very happy to answer.